ओके बॉयज, चलो स्टार्ट करते हैं एक ये प्रॉब्लम. Alright, I am signed in, right? Let's reload once. Right, okay. So we have this problem, Roman to integer. Roman numerals are represented by 7 different symbols: I, V, X, L, C, T and M. I 1, V 5, X is 10, L is 50, C is 100, D is 500 and M is 1000. For example, 2 is written as, thus in Roman numeral, just ones added together, and 12 is written as 10, which is simply x plus 10. The number 27 is 2 2, right. Roman numerals are usually written largest to smallest from left to right. Largest will be the leftmost and the smallest would be the rightmost. Okay. However, the numeral for 4 is not. Instead, the number 4 is written as IV because the 1 is before the 5. Because the 1 is before the 5, we subtract it, making 4. The same principle applies to the number 9, which is written as IX. There are 6 instances where subtraction is used. Okay, IV and IX 4 and 9, XL and XC to make 40 and 90, and C can be placed before D to make this, right. MCM, and C can be placed before D or M to make 400 and 900 respectively. Okay, so right, so what I will do is we will I have this string. Okay, we have first 3. So for the most basic, what I will do is I've created a map, right. I've created a map slash dictionary for it, and what I will do is simply go through each of the characters, right. Check uh, check whether okay, and check what it means, and simply add it, give it a running sum. This should be the easiest. So I have already created a map of dictionaries, right. Then we convert the strings to a list of characters. Do I really need to do that? Okay, first I want to done one. Then I need to check for I in print I. Do I really need to convert it into a list of characters? Okay, no, I don't need to convert it into a list of characters. It is by default a list. Then okay, we loop through the list and sum consecutively. Alright, for I and S, I'll sum is equals to 0. Then what I'll do is I will go dict. I should not use dict. I just say M for map. We'll go sum equals sum plus M of I, and at last we're done sum. this is the simplest, and it should guarantee that I get, yes, two cases right. I get 3, I get 2, but this is not right here. Okay. Now, right. Okay. Now what I need to do is I need to check. What do I need to check? I need to check these conditions. One is placed. Okay. Now I'm thinking. Okay, there are two ways where I can check. One with v and x. Then we have x. I think x with we have x with L and C. So with L and E, and finally we have C with D and M. C with D and M. Okay. Okay, if I encounter and I, it is subtracting 1, right? If I encounter an I and the next character in the list, but how would I know the next character if it is not what do we say, if it is not a list, right? Okay, so I will, if I ever encounter I and the next character is either V or an X, then I, instead of going sum plus, I will go sum minus, right? Then similarly, if I encounter an X and the next character is either a L or a C, so for that I would need to, for I in range length of S string, and I would need to do S of I. So first we'll check that it should, right? Okay. Now if S of I equals what? I. Okay. Specific conditions. So I equals to I. Now I will look ahead if S of I plus 1. If I and I plus 1 is less than the and I is less than len of S minus 1. It should be less than the range, right? Okay, then I can put this condition if I is less than A, and then I can, and S of I equals to either a V or S of I is either a X. If this is the condition, then we will say that sum equals sum minus of s of I, right? I feel like if I is less than s of I, continue, not similarly if I is less than, I need to look ahead, I plus 1, I plus 1, I plus 1, then continue if s of I equals what did I discuss, an x, right? And s of I plus 1 equals either a L or a C, either an L or L then we continue. Or a C, then because MCM x squared C, that is 90, sum equal to sum minus, oh I would have used a label here, which would have been really helpful. Go to even a switch statement would have been great. Sum equals to sum. Then because I'm basically okay, I will just set a flag creating a flag to either subtract or add the value, right? I'll say flag equals false. Okay. Flag equals true. Then same here. I will go else if flag equals true, and else if I must set it false in the beginning. Right, okay. If f of I equals what is the last condition is C for D and M. C and of I plus 1 equals D, or f of I plus 1 equals either M, so flag equals true, right? And depending if flag is true, then we subtract it from the sum, and if else we add it into the sum. Let's try and run this. And yeah, that's basically it. Yeah, depending on the flag, we either subtract or if else if. And if I submit it, ooh, I am very slow. I am very slow. Okay. Then what could I have done different, right? Here's the O of n solution, right? With string comparisons. Because I needed to look ahead, sum return sum. I created a map, right? I got the solution, but I have to be better than that. No. Okay, let's see what could I have did. Flag. Registration is now closed. 8 week. Okay. Let's see.
Hey guys, Greg here. Let's solve Roman to integer, LeetCode number
What could I have done different?
13. So Roman numerals are represented by 7 different symbols. We have I, which is 1, V, which is 5, X, which is 10, and you can see all the numbers in this table here. So for example, 2 is written as II in Roman numerals, just 2 ones added together. 12, however, is XII, which is X, which is 10, plus 2 I's, and so that's 12. Now the idea here is that Roman numerals are usually written largest to smallest. So see here like XXVII, they're generally getting largest to smallest from left to right. However, the numeral for 4 is not III. Instead, the number 4 is actually written as IV. So the smaller thing is coming before the bigger thing. So because the 1 is before the 5, we actually subtract it, making 4. So instead of I plus V to get 6, it's actually V minus I, which is 5 minus 1, which is equal to 4. There's actually 6 instances where the subtraction is used. And so basically just given a Roman numeral, we need to convert it to an integer. Okay, so S is the string of I. The answer is 3. If S is 50 plus 5, which is 55, plus 3, you're going to get 58. And if it's this crazy one, you're getting 1,000 from the M. And then you actually have a CM, and C is smaller than M. So it's actually plus 1,000 minus this 100 here. So 1,000 plus 900, we have 1,900. We have X and then C, and so that's actually going to be an additional 90 because it's 100 minus 10. So we have 1,990, and then we actually add a 4. So 1994 is going to be that final answer there. Okay, so let's use this example right here. Now, just as a convenience factor, you'd want one way of looking up via a letter to know what its corresponding value is. And so you could use like a hash map for that. So say M is going to take on the value of 1,000. You'd have C is going to take on the value of 100, so on. I is going to have the value of 1. You would want some sort of a hash map or way of looking up a letter's value. Okay, then from that, basically we are going to use one index I, and we are going to have a variable which we'll just call sum, which is what we have so far. We're going to build it up left to right. So we'll initialize that as 0 so far. Okay, so let's trace through the string here. Well, do we want to add this or do we want to do any subtraction? Well, you want to add it as long as this value here is actually bigger than the one on the right. And it is. M is 1,000, C is 100. And so we are going to just add the value of M. And so far we have 1,000. Okay, we only used M, and so we moved the index only over one space. Well, if we compare C to M, we'd actually see that M is greater than C. So the value on the right is bigger than the one on the left. That means you want to add a subtraction. You get the value of M, which is 1,000, and you'd get the value of C and subtract that. So you'd actually want to add this value. You'd want to add 900. So we add a 900. So now we're at 1,900. And now in this case here, you need to move your index over 2 positions because you've actually used this whole piece right here. So when you do the subtraction part, you actually want to move it over 2 positions. Now the same thing happens here. We actually know that C has a value of 100, which is bigger than X, which is 10. And so you're going to add the difference. So you would add 100 minus 10, which is 90. So you're going to get an additional 90, 1990 so far. And again, in this case, we did our subtraction piece. We used both the X and the C together. You want to move your index over 2 positions. Here, it happens one more time at the end. 5 is bigger than 1, so you want to add 4. You're going to get 1994, and you're going to move your index over 2 positions. And you would be done and return your answer. Now, before we do that, let's just look at a potential edge case here, which is if we had an I here, well, then what would actually happen is over here, you would have added 1. You'd move your index over here, and you want to make sure you don't look out of bounds here, because if you did look out of bounds, well, then that's going to cause an error. So you only want to look ahead if that's actually possible. And so this last position here, which is always going to be n minus 1, so the length of your string minus 1 will be your last index. You only really want to be able to look ahead if I is less than n minus 1, because if I is actually equal to n minus 1, that would look out of bounds. So just watch out for that edge case, and other than that, it's not too bad. Okay, so the first thing we'll do is just get our different values in the hash map. So I'm just going to paste that in because it's kind of annoying to type here. But we have that I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1,000. Well, our current sum is equal to 0, and we'll get n, which is the length of our string. Then we'll get our index I, which is equal to 0, to start a while loop. So we want to do this while I is less than n. So we might want to do that subtraction piece, except you need to make sure that you can actually look ahead in the array. So that edge case we just discussed there, you can only check ahead if I is actually less than n minus 1. Okay, if that's true. And the dictionary value, so D at S at I, if that is less than D at S at I plus 1, so you can think of D as just the value of this piece here. So if the value of the left character is less than the value of the right character, then okay, we want to actually add the difference to them. So we want sum to go up by the value of S at I plus 1, so the right character minus the value on the left character. And in that case, you actually used 2 different positions, so I must go up by 2. Okay, otherwise, we must be in the case where you just want to do addition, and so your sum is going to go up by your value, which is D at S at I, and you only used 1 character, so I is going to go up by 1. At the end of this, you can simply just return your sum, and this is going to work in a time complexity of big O of n, and we're not storing anything at all here, and so the space complexity is going to be big O of 1. If you run that, that is going to work, and I hope this was helpful, guys. Drop a like.
Okay, now let me see that. If we sum n equals to length of s and I equals to 0, then instead of the as we start with I is less than n, and if I is less than n minus 1, and m of s of I is less than m of s of I plus 1, then we say sum equals sum plus this value minus this value. Alright, and if it's not the case, then we simply, and okay, we have to increment I by 2, and if it is not the case, then we simply add the value can we simply, okay, so indentation error, okay, and it should work. No, unindent what is wrong with this? Unindent does not match any outer indentation levels. Okay, I don't actually understand. Less than n. Okay. That is where I have to put it. Okay. I hope this fixes the solution, the problem. Okay. And will it be better than 15 millisecond? I think it will be better. Dude, significantly better. Okay. Okay, so we look ahead, we subtract by 2. Let's do some consecutively. Right, so what we do is we take and we look at if this is less than this, then we subtract the values of these and we increment I by 2. Okay, I got it. Now, okay, let's look at O of n solution. I'm done with this. Is a subsequence. Is a subsequence. Okay, what is a subsequence? Okay, do I want to try that in C++2? I think I should try it in C++2. Now let's go at C++. I have a string as map of string and integer m, and I think I can provide it a value of let's say I comma 1 comma v comma 5 x comma 10 l comma 50 c comma 100 d comma 500 and m comma 1000. So this is a map for referencing the values of Roman numerals, right? Then we will start with an sum equals to 0, index equals to 0, and length equals to s dot size. I figure it is some string size g. I figured that was because I would need to check actually. Oh, maybe it's great here. Okay, arrays and strings. No, I need to take a look at C++ CPP. Primer string. Okay, strength and string. These string data types. Yes, size type. There was string size. Okay, size underscore auto length. String size underscore type size. String size type underscore len equals to s dot size. Declaring initializing the declaration and definition, and looping through the string. So we'll go for and I equals to 0, I should be less than len. Then we will check if I is less than len minus 1 and m of s of I is less than m of s of I plus 1. And in this case what we will do is we'll go sum equals to sum minus m of s of I plus 1, sorry, plus we'll add the difference. We are going to add the difference, and else we simply add it, and we have to increment. Yeah, okay. So while I is less than n len, then we we must also increment the I by 2 and increment I by 1, and at last we return sum. We return sum. Let's try and run it. If I oh sorry, okay dude, I think I must have messed up here. This is that. Okay, great. Now no viable overloaded operator, string string string. I don't understand. At line 14, M of S of I. No, it doesn't work like that. I cannot reference a string like that. Okay, hold up. How do strings used to work? String intro, right? Strings, yeah. Name operations. Empty, not empty. Style. Then I can add them. Dealing with characters in string, right? I can do this, then do a voice punct, processing only some characters. Yes, okay. Using subscript, I can use the subscript operator. Displaying character at index 1. So subscripting actually works. so I so I don't understand why won't it if I is less, if I is less than len minus 1 and yeah map of okay. How does a map work? How does a map work in C++? Mm, C++ primary, yes. Defining associative. Okay, we have map, yes. Okay. Map string size. String, comma, size string. Empty map. Then I can define word count string. Right. Map. Okay, like this string, right? Then requirement of key type. I don't care about that. The pair, yes, pair. Mapped value, map key value, map type, associative containers, map first, trading across, and algorithms. Adding elements. Yes, okay, word count. When we insert into a map, we must remember that the element is where we don't have a pay object that we want to insert. insert string size t, argument insert m place insert. Okay, testing the return from insert. What does insert returns? Insert, can I not can I not use the subscript operator for the value? Subscripting a map, yes, subscripting a map. Operator corresponding word count Anna, right? Equals to 1. Check access to the element with key. Returns the element with key of k. If k is not in C, at the returns the element that is the value returned by a subscript operator. Okay, fetch the element and add 1 to it. Print it. Okay, so it can fetch, prints 1. They have given Anna value 1, so it fetches 1, right? That's what I have done, and I don't understand why operator no viable overlay map string int map string m s of I. Okay, m of s of 0. Sorry. Okay, I plus 1. Let's forget about this for a while. Let me just figure out how can I my map m of I. Can you print that? Yeah, straight out I can go for anything, right? That's how the map works. Right. Okay. Now s string s, right? I s of I. It won't work like that. Okay, no problem. Then I can simply string s equals to say string t equals to s of I, and then we t. Okay, still okay, s of I, no variable conversion of char to a string. I but char to a string. Okay, then this shouldn't be a string. This should be a char. Because it returns a char. Now I get it. Subscripting return the char, and that's why. Okay. So then this should automatically work. Char, right? Because I'm providing a char. Yep. That is all. Okay. Okay, so but we'll get there. I just need to understand how these things work. We look ahead. Right. 45 minutes. Alright. Then all of my are saved, right? This C++. Okay, great. Then let's try if subsequence. Okay. Given two strings s and t. I'll try in Python first. Return true if s is a subsequence of t, or false otherwise. For example, a subsequence of a string is a new string that is formed from the original string by deleting some, can be none, of the characters without disturbing the relative position of the remaining characters. S and T, if S is a subsequent. Example, A is a subsequence of A, B, C. Okay, so it is fairly easy. I start a loop and I will just advance it. Okay, I'll look if it is here. Then I'll advance it, I'll advance it, I'll advance it. And sure, AEC is not. Okay, this is fairly easy. This is very easy indeed. I think we can get it done easily. Okay, so I have this string ahbgtc. Okay, ahbgtc. I go through all of the characters, right? Then I have A, B, C. I put my index here. If it matches, I increment the index. If it don't, well, if this cannot be, if like say A, C, E, right? Well, AEC is not. AXCF, ABC, then AXC, AXC. X won't be found. So it is easier to start a running loop, right? But say, however, if C comes first, well, it doesn't matter because I should find it here, right? If right, I'll start looping through this. Okay, let's get started. Right, so I equals to 0, then for say k n t. Okay, and I should match the length, right? I should length L equals to len of s. I should match the len of s. Okay, if s of I equals k, then we go I plus equals to 1, else we do nothing, and in the end we check if I equals L, then we return true, else we return false. Let's try and run this, right? The subsequence for okay. Alright, okay, this is a user case, this is a test case where S is null. Okay, then if L equals 0, we return false. Quickly, let's try it again. Okay, this I was expected. Okay, S is nothing. If S is nothing, we return a true. Last executed B string index out of bound. Let's just say and I is less than len and I is less than L. If I equals okay, so I will start it at -1 and I'll say L -1. Let me try this first. Okay, these two run great. Case 1, I -1, L equals to 0, return true. This is really confusing. We can index out of bound, right? So there has to be a better solution for this. And I is less than L. Okay. So if I equals to k, string index out of range t, k in t. And because I think the AND operator computes from left to right, so it's easier to check if I is less than L. First, let's submit it. I hope it works the same in Python. Yeah. Okay. Right. This was really easy. I had an intuition that it was going to be easy because we simply just had to check if if it follows the sequence. And I think if I remove this, it should still work because I won't have to check for that edge case. Yeah, great. Because because 0 is not less than 0, so it is automatically false, and it returns a true because I am saying that both the values should be equal. Okay, we are still left with 5 minutes, so let's implement the same in C++. Okay, is subsequence will start with int I equals to 0 and size type len equals to s dot size. Then I want to for char c and t loop through if go with I is less than len. Yep, len less than l, and s of I equals c. Then what we can do is we can go I plus plus, and at the end of the loop, if I equals len, then we return true. This is not Python, my man. We return true, else we return false. It should work according to me. Yep. And great. Right. I think my mind, I guess I'm still left with some time, so let's check the solution for this. I have completed a subsequence.
Hey guys, Greg here. Let's solve is subsequence LeetCode number 392. So we're given two strings, which we're going to call s and t, and we need to return true if s is a subsequence of t and false otherwise. So a subsequence of a string is a new string that is formed from the original string by deleting some, or basically none if you want, of the characters without disturbing the relative positions of the remaining characters. So i.e. ACE is a subsequence of A, B, C, D, E, because if you delete B and delete D, then you're left over with A, C, E in a row. So ACE is a subsequence, however AEC is not, because even though those letters are contained in the string, you lose that relative order. Okay, so in this example here, if S is ABC and T is AHBGDC, you can see A, then B, then C. If you delete H and you delete G and D, you're going to be left with ABC, and so here you'd return true. In this example here, AXC, well, we don't see X really anywhere in the string, so that's definitely going to be a false. Okay, so let's use this example where S is ACF, and we do see that as a subsequence of T. We can see A, C, and F, so ultimately this one would return true. So the idea here is to basically use an index for each of the strings, so we'll give I to T and J over to S, and then we just need to keep checking if they match. So yes, they do match. Okay, then we're going to move j over, and we're also going to move I over. Now do they match?
Okay.
Well, they are not matching. T at I is not equal to S at j, and so we cannot move over j because we haven't found this character C yet. We're still looking for it. So we'll just move over I, and now we can see that they do match. So we're going to move both of them over in this case. They do not match here. We just move over I. They don't match here. Just move over I. Since they match here, we actually matched
what I
at the
did,
very
actually.
last character here. So you would return true
So
because j got
it
to
is
the end of the string.
like
If we actually had the
it
case
was
where this
about
was,
the
say,
I
a
think
G, then what would have happened?
this suits better for the case. What I was thinking was basically that if we have B somewhere before C, no, but then it would not be in order, basically. Yeah.
Happened here is that
So
I would have gotten to the end of this
my
string,
solution
and
is
if I
better than
ever
this
gets to the end of the string
for the first
before
time.
j gets to the end of its string, then that's going to be a false. So that's really all there is to it here. You would use these two indices to basically just move them along. Whenever they match, you move them both over, and if they don't match, then you're just going to move over I. Okay, so we'll get capital S is T. That actually is false to greater way you can find a subsequence that's bigger than another the strings at all. Okay, otherwise, we must have that T is at least the length of S, so we can loop through
okay,
them.
so
We'll get
the new
J
thing, I guess, the new thing that I have learned is because this basically corresponds to a boolean, so I can use and return the boolean itself. See, there we go. Easy. Easy. O of n solution. Great.
through I a match, so then we want to move over both the
This
indices.
is a little complex. I
We
think
got
mine
simply if
better.
is going to be big O of 1
1.
because we're not using any data structures. Okay, if you run that, that is going to work, and I hope this was helpful, guys.
Okay, sir, we take our